Hello, welcome back to Mastering Statistics. We're going to work an actual problem where we're going to tackle the following. So test at a 95% level of confidence if there is a significant linear relationship between the number of absences and the GPA. Now what this is basically saying is if you plotted the number of absences versus the GPA, so here's a student, here's a student, here's a student, here's a student. These are each individual people. And this person missed 0 days, this person missed 0 days, this person missed 0 days, and so on, we record their GPA. It kind of makes sense. You would think that if you're absent 8 times, you're probably not doing as well. So your GPA is lower than the person that's actually there all the time, but of course that's not, you can't just draw that conclusion. So if you were to plot this, you're kind of wondering if you would see a linear relationship. And of course, the closer these points fall to an actual line, the higher that correlation coefficient is. But we're not just asked to calculate the correlation coefficient. We're asked to test at a 95% level of confidence if there's a significant linear relationship, which means if we're basically using this data to figure out if the population correlation coefficient is different from 0 or not, using this data. And there's 15 data points here. If you count them up, there's 15 of them. So what I'm going to do over here is just start, actually I'll do it right here, start writing down everything that we know from the problem. That is really the step one of all of these things. Okay, the first thing is, what is the null hypothesis? It's going to be the same for every one of these problems. That the population correlation coefficient is 0, which means there's no correlation between these values or these ideas or these variables. And the alternate hypothesis has got to be the mathematical opposite of that, which means that the correlation coefficient of the population of students is not 0. It doesn't mean close to 1 or not close to 1, it just means it's not 0. Because if the population correlation coefficient is anything other than 0, then there is some sort of relationship there. It may be weak, but there's something. Okay, so that's the first thing we want to write down. We always want to write our null and alternate. And then we go and look at the problem, and we see that the level of confidence is given to us. How confident do we want to be in the result? That's given as 95%, which in terms of math is 0.95. Now, from the level of confidence, we always, in these types of problems, we always deal with the level of significance. So it's 1 minus 0.95. So then alpha is 0.05. You should know that just because you've probably done a million of these problems already. So the level of significance, alpha, is 0.05. Okay, that's the second piece of information that we're going to write down, just kind of keep to ourselves. And now we want to start talking about what will the rejection region look like. We're going to draw a picture in just a second, but we want to write down everything that we can first. Now, look at our null and alternate hypothesis. The alternate hypothesis has a not equal sign, which means it's a two-tailed test. So I'll just write that down since our first problem. It's a two-tail test. And all of these problems that we're going to do essentially are going to be basically two tails. The other thing we want to write down is how many samples do we have? I told you if you count them up, you'll get 15. So we know that the number of samples is 15 samples. We're going to need that number to look at the value of t in our book and also to calculate the test statistic. And also because we need it for the degree of freedom. The degree of freedom for all of these problems is n minus 2, which means 15 minus 2. So the degree of freedom is going to be 13. So that's an important value we're writing down. And then what we're going to do is we're going to try to define this rejection region. So I'm going to change colors and put this in blue. What we're trying to find is T alpha over 2, the boundary on the right-hand side with a value there. So let's go ahead and before we actually